Hello and welcome to Building Robust GraphQL APIs with AWS Amplify and AWS AppSync. My name is Nader David. I work on the AWS Mobile and AWS Amplify team, and I am a developer advocate. And what we're going to be going over today is really kind of a deep dive on how you can actually use the Amplify library along with AppSync to add a lot of functionality with not a lot of work, not a lot of code, and also kind of how to understand how to add the types of functionality that go past really the hello world type of application and into something more production ready, more real world, more of the types of applications that you'll end up building once you kind of get the basics down. So what should you expect from the session? This is kind of going to be what we're going to be going over. We're first going to do an overview, a general overview of AWS Amplify. Once we are done getting an understanding of Amplify, we're going to then take a look at AWS AppSync. We're not going to dive too deep into exactly what AppSync is. We're going to assume that you kind of already have a decent understanding of that, but we will give a general overview of AWS AppSync. We'll then talk about the GraphQL Transform library, and really the entire talk today is really going to be focused around this library. And we're going to talk about what exactly it is, but in general, essentially it is a bunch of directives, a bunch of decorators that you can add to your GraphQL schema, and then using the Amplify CLI, you can add functionality to your GraphQL API. We'll walk through all of the GraphQL Transform directives that are available and talk about what each one of them does. We'll then jump into a live demo where we'll use all of the different directives that we went over in the previous portion of this presentation and actually build out and test a real GraphQL API. Some of the things that we're going to be going over today are how to add authorization rules to a GraphQL API. We're going to look at how to add relationships, so one-to-many and many-to-many relationships into your GraphQL API. We're also going to look at how to add different types of keys to your database that's going to be generated by the GraphQL Transform library. So if you need to do things like sorting, if you need to do things like specifying your global secondary index or even your hash key, we're going to look at how that you can do that using the GraphQL Transform library. And then finally, we're going to look at how to use the very powerful @model directive. And this is kind of the base level directive that gives us all of this other functionality that generates a lot of the different databases, resolvers, and additional schema that we're going to be using. All right, so let's keep on going now. What is Amplify? So if you're here, you probably already have a general understanding, but if not, we'll give a quick overview. It's a CLI and a tool chain for the client, and there's also the Amplify console, which we're not covering here, but the Amplify console is a hosting platform. The CLI is a command line interface, of course, and it allows you to create and configure AWS services directly from your front-end environment or from your terminal, or from Cloud9 also. It also consists of a JavaScript library or a client library in general if you're using native iOS or native Android. And once you've created your services from the CLI, you can use one of these client libraries to then interact with the services that were created by the CLI. So what kind of services are supported? We continually are adding new services. So for example, we very recently added machine learning and AI services. But in general, this is kind of a very good overview of what you can do with Amplify right now. You can add databases, you can add different types of APIs, both GraphQL and API Gateway with Lambda. You can generate Lambda functions. You can also add authentication, analytics, hosting, storage via S3, and chatbots. And there's a few other utilities that are part of the Amplify client library on the front end that don't really have any specific AWS services on the back end, like internationalization. So let's take a look at a couple of the services that we're going to be using today. For authentication, we're going to need to specify authentication rules on our GraphQL schema. And we're going to need to add authorization rules for interacting with our GraphQL API in general. So to do that, we're going to need to set up some type of authentication service. And with Amplify, you can set up authentication using the API category, which under the hood utilizes Amazon Cognito. Amazon Cognito is a user management service, and it's completely managed. And what it basically does is it allows you to sign up users, sign in users, and just manage all of your users. And from the CLI, you can create and configure new Amazon Cognito resources. From the client library, you can interact with this user service by signing in, signing up, and interacting with different mechanisms that you would need for user management. We also have pre-configured components available for JavaScript libraries like React, React Native, Angular, and Ionic. And we also have pre-configured components for native iOS and native Android. So after you've created this service, you can use these pre-configured components to kind of get up and running quickly with a real user interface. The other service that we're going to be working with from Amplify is AWS AppSync, and it's categorized under the API category. So what is AWS AppSync? Essentially, the general overview is that it's a managed API service, and it utilizes GraphQL as the implementation. You can basically, from the CLI, do all of these things. So you can create AWS AppSync GraphQL APIs. After you've created your API, you can then continually configure, update, and manage your API. So the base schema that you start off with can evolve, and you can evolve your schema from the command line. Using the Amplify client library, either on native or JavaScript, you can then interact with the AppSync API. So once the API is there, you want to then query against it, you want to send mutations, you want to register for subscriptions. You can do all of that from the client libraries. And then part of the Amplify CLI that integrates directly with AppSync is something that we're going to talk about today called the GraphQL Transform library. And the GraphQL Transform library is a series of directives or a library of directives that allow you to decorate a base GraphQL type to add additional functionality. So what we're going to be really focusing on here is how to use the GraphQL Transform library. So let's take a look at some of the different transforms that are available to us. The main ones that we're going to take a look at today are @model, @auth, @connection, and @key. We also have @versioned, @function, and @searchable. Since we're covering the 4 that I mentioned, I'll also just go over really quickly what @versioned and @function and @searchable do. @version allows you to have versioning in your API, of course, just like the name sounds. @function allows you to specify a Lambda function as your GraphQL resolver. So a lot of times people would like to implement microservices or existing other backend services that aren't directly accessible from AppSync at the moment. To do that, it's pretty easy to do anything you would like in a Lambda function. So a lot of times people use this @function resolver to add a Lambda function. From there, you can write whatever code you'd like and then have the response returned into GraphQL. And then we have @searchable. @searchable allows you to deploy an Elasticsearch instance using a combination of @model. So therefore, you can have not only the base search functionality that you would get out of DynamoDB, but you extend that to everything that Elasticsearch, and it integrates directly with the DynamoDB instance. So essentially, when you create an operation and you store it in Dynamo, we also stream that to Elasticsearch. So once the operations are created, once the data is there, you can perform queries either against DynamoDB or Elasticsearch. Once you delete items from DynamoDB, we also extend and delete those from Elasticsearch. So it's kind of like having 2 databases available to you. That way, a lot of times you're limited for certain reasons for what you need to do that isn't available in Dynamo or in some database. Elasticsearch extends kind of the functionality and allows you to perform, more complex queries using Elasticsearch. But now we're going to go over @model, @auth, @connection, and @key. So @model is a very, very, very powerful directive, and it's something that we're going to be using for pretty much all of our fields. And what it does is it allows you to take a base type, decorate with this @model field, and then we actually then scaffold out a bunch of different functionality for you based on a lot of pre-configured specifications that a lot of best practices are based upon in a lot of customer use cases, a lot of things that people do with their APIs. So for example, CRUD operations, we generate create, read, update, delete, and list operations in your GraphQL schema. We then create the resolvers that integrate with those operations, and then we also generate the database. And then also we generate the subscriptions as well. So to use @model, you might have a GraphQL type that you've created like this in the past, and then you might want to have an operation like create to do, update to do, delete to do, etc. Essentially what you've had to do in the past is define those operations as either queries or mutations in your schema. You then had to write the resolver code that interacted from that operation into your data source. And you also, of course, had to set up that actual data source. But if you use GraphQL Transform, you can just add this @model decorator. This will go ahead and generate all of that stuff for you. You can then take what we've generated and modify it to whatever business use case, whatever data that your business logic or whatever that your application needs. So we kind of generate some best practices for you, some boilerplate. It works for a lot of use cases, but if you need to extend that, you can go in and easily make changes and then model the different resolvers and things like that around your own specifications. So essentially, @model adds create, read, update, delete, and list operations to your schema. It adds a DynamoDB table, it adds the subscriptions, and it adds the resolvers for all of these operations. The next transform we'll take a look at is @connection. So when people are getting up and running with GraphQL, a lot of times people have a lot of problems getting started creating relationships between their data. So @connection is basically something we brought forward to help people get started much easier with those relationships. And what we end up doing is allowing to just specify an @connection between different types. And what happens under the hood is we do all of the work of creating the resolvers and any possible global secondary indexes that might need to be created on the table to do things like searching on a field or on a type within the @connection. So to use this, you might have a GraphQL schema that looks something like this. You have two types of data that need to have relationships with each other. So here we have a type of post. The post has comments. And we have a type of comment, but the comment doesn't really know about the post. So how can we make it to where we can create a post and then create a comment from within that post? And we don't want to actually have to write all this code. All you need to do is add the @connection directive. And then here you can give the name of the connection. And then if you'd like to have a sort field, you could specify that as well. So here we're adding post comments as the connection. And we're adding post as the type under comment. And this will automatically generate all of the necessary resolvers. It will also add a global secondary index in the table for the comment table for us to be able to query based on the ID of the post. So when someone creates a post, someone create a comment under that post, we can then query for comments based on the post ID. So @connection, again, model relationships between your data. The CLI will then create the necessary resolvers based on the @connection declaration. The next transform we'll take a look at is @auth. And this, as it sounds, enables you to add the ability to specify authentication rules. So authentication is, one of the most complex things that you'll probably run into when building out the business logic of your GraphQL application and when you're dealing with things in your resolver. So what's the easiest way to kind of get up and running with some basic rules? Well, @auth is pretty easy to get up and running with, and it allows you to have a lot of control at a very high level of your resolver. So take, for instance, a base type of post. And say, for instance, we created a blog application, and we wanted this post to be readable by everyone, but we only wanted the creator of the post to then be able to update, delete, or modify the post. How could we do that without having to, write a bunch of code? Well, we can add the auth directive, and then we can pass in the rules that we would like. So if we passed in the @auth directive and we passed in the rules property, and we only set allow to owner in this array, and we did not specify queries null as you see here, then only the owner would be able to read this post. But we can also add additional rules after we set the allow property. So for instance, for a blog application, we actually want everyone to be able to query against this post and read these posts. So we pass in the queries property and we set that to null. So this means that only the owner can update or delete this post, but anyone can query against this post. Therefore, we're setting no rules under the queries. And there are a bunch of different ways that you can configure this. In fact, you can pass in an array of different rules. So for instance, another popular use case is having different fields that are available based on the group that the user's in. So if you're an admin, we might add another property to this array that says allow groups, and then we can pass in an array of groups that can then access this this post. So if we did pass in, say, an array and we added the admin, if someone was an admin, they would also be able to access this post as well as the owner. So at auth, there are quite a few different ways that you can configure this. If you check out our documentation, you can get pretty in-depth with how you can model your data here. But essentially, it allows you to define authorization rules. And then the last one we're going to take a look at before we actually build out our application is @key. And @key is something we recently added that enables the ability to configure a custom index structure for your @model types. So if you've created your database using @model and you want to specify things like the hash key, you want to specify things like a certain way that you want to have a sort key or anything like that, or maybe you want to specify a global secondary index for you to query against, you can do all of this with @key. And the way that you might do that, let's say we have an event type, and when someone queries for these events, what we want to happen is we don't want to just get all of the events back in a random list. We don't want to have to deal with sorting that on the client. We don't want to have to deal with that. But maybe we have an application that lists events in order from which they were created. So how could we have an API where when we queried against this API, it would list the events in the order that they were created? So to do that, we can add the @key, and we can set a few different properties. First of all, you have the optional ability to set a name. And this name is going to specify the global secondary index. So this isn't going to be the main index, the ID. This is instead going to be a new index that we're creating called query name. And then we're going to also have an array of fields. The first field is going to be the global secondary index that we'd like to query against. The second is going to be the sort field. So we'd like to sort by created at. And then the third argument is going to be the query field. And when we pass in a query field, this is basically just going to create a GraphQL query that allows us to query using this these additional fields. So we'll have a way to list all events, but we'll also have a way to query events by date. And the query field that we're creating is items by date. So we can basically then query these items by date. And we'll take a look at how to use all of these in just a second. So essentially, key is a directive that allows you to configure custom index structures. So how do you use Amplify CLI and do all this stuff? We're about to take a look at how to use it, but how do you install it? npm install -g at aws-amplify/CLI. Once you've installed the CLI, you can initialize a new project by running amplify init. Once you want to add a new feature after the project has been initialized, you can run amplify add with the name of the feature. What we're going to be doing today is amplify add auth, and then we're going to be doing amplify add API. So All right, so let's go ahead and demo this out now. So I'm going to go ahead and jump to my terminal window. So here we are in an empty folder. And what I'd like to do first is initialize a new Amplify project. So I'm going to run Amplify init, and this is going to walk us through the steps of initializing a new Amplify project. So I'll go ahead and set some basic default configuration for this project. I'm not working in a React or a Vue application, so I'm not really worried about the different build and run scripts. But I'm going to go ahead and set the project name and the environment for now. I'll go ahead and set my AWS profile. I'll go ahead and pick US East 2. And this is going to go ahead and generate the base Amplify project. After we're done here, we'll go ahead and add our authentication and then our API. All right, so after the Amplify project has been created, we should now see our Amplify folder, so we can now start adding a few features. So the first thing I want to add is authentication. So I'll go ahead and run Amplify add auth. This is going to go ahead and walk us through a few different steps. We just want something really basic because we just want to test out authentication in our API. So what we're going to do is set the default configuration. We want to be able to sign in with a username, so we'll choose username. And that's really about it. And that will go ahead and set us up with authentication. So the next thing we want to do is go ahead and get to our GraphQL API. So I'll go ahead and run Amplify add API. The API we'd like to build is GraphQL. I'll leave the API name as GQL Transform. And we want to set the authorization type for this API as Amazon Cognito user pool using the authentication service we just set up a moment ago, which is implementing Amazon Cognito. So we can choose that. Do we have an annotated GraphQL schema? If we did have one, we could choose yes here and just link to the path that it was located, but we don't. So I'm going to go ahead and choose no, and this is going to be where we create our custom GraphQL schema. I'm going to go ahead and choose yes to guided schema creation, and I'm just going to take any of these projects because we're basically going to be overriding them anyway. And I'll go ahead and choose yes to edit the schema. And this should go ahead and open the GraphQL schema in our text editor. So this gives us the base type of to-do, and you see that we automatically are giving this directive of @model, and that's great. We're going to be using that @model, but we're going to be getting a little more complicated than that. So I'm just going to go ahead and delete this, and I'm going to talk about the type of app that we're going to be building today. We're going to be building two parts of this API to kind of demonstrate a couple of different types of applications that you can build. We're going to be building one type of kind of like a blogging app where we can have a post and then we can have a comment. And then we're also going to be building an events app, so where we can basically create an event name. And with the events, we're going to be using the @key directive so we can do sorting. And then for the blogging app, for the posts and for the comments, we're going to be implementing authorization, and we're also going to be implementing the relationships with the @connection. So the first type we want to go ahead and create is post. And here we want to go ahead and add the @model because we want to go ahead and generate the additional schema as well as the resolvers and the database. But we also want to add @auth. And for @auth, we're just going to pass in now a rules array. And this rules array is going to specify exactly what we would like going on to happen for our authorization rules. So what I want to do is I want to allow the owner. So if the post was created by me, I want to be able to edit, update, delete, and also query for it. But I also want to set the queries rules to null, because if I am also a guest user that didn't create this post, I also want to be able to just read the post. And that's kind of about it. Everything else is going to be just basic GraphQL fields. So I'll go ahead and give the post an ID, a title, and a comments array. And we're going to get back to this comments array in just a moment. Let's go ahead and create the type of comment. And this is also going to have the @model field. And what we're going to do here is give the comment an ID. We're going to give the comment a content. And we're also going to be created at. And now we want to define our relationship between comments and the comment post. So what we're going to do here is we're going to add the comment as the array. And then here we can specify the @connection. And then @connection is going to have a name. And then it's going to also have a sort field. And the sort field is going to be created at. And we can also kind of just copy this and use it here, because what we're going to do is have a post as the relationship with the comment, and then we can specify the type of post as the field of post, and then we can add the same connection information. So we also want post comments as the name to match this, and then we also want the sort field to be created at. Okay, so that's our blog. This should allow us to be able to create posts, create comments on the post. The next thing we want to do is have a type of event. And this event type is going to be a little different because we want to add the @key directive here and add some search capability. So what we're going to do is have an @model, and we're also going to have an @key. And we're going to specify those key rules in just a moment. But first, let's go ahead and specify the fields on this event. We want an ID, we want a name, we want a created at, and we're also going to add a new field called query name, because we want to associate a consistent field across all of our events, because we're going to be performing a query against our DynamoDB table as opposed to a scan. And in order to perform a query, we need to be querying against a field within our GraphQL type. So the field that I'm going to create is query name, and this is going to be consistently named event across all of our operations. So in the @key, I can now go ahead and specify the name for the global secondary index that we're going to create, and this is going to be query name. I'll also define the fields array. So the first item in the fields array is going to be the global secondary index, or the index that we'd like to have as the query. And this is going to be the query name. And then the second argument is going to be the sort field. And for us, that's going to be created at. So the last thing we want to do is add a query field. And this is going to go ahead and allow us to define a GraphQL query that we'd like to use using this new query that we've created to list items by created at. So how can we query this sort field basically? And for the query field, we're going to call this items by date. This could also be something like events by date. So now I'm going to go ahead and save that and jump back to the command line. So now we should see that the GraphQL schema compiled successfully, and I should be able to go ahead and run Amplify push, and this should go ahead and deploy not only the authentication but also the GraphQL API. Now we have the option to generate the GraphQL code locally for our application. If I was building a client application, I would probably choose yes, but since I'm only worried about the API for this demo, I'm going to go ahead and choose no. All right, now that the GraphQL API and the authentication service has been created, we can now start testing everything out. So the first thing I'm going to do is I'm going to go ahead and open up the code in my text editor, the Amplify project. And what we're going to do is we should now see that we have an AWS-exports.js file that was created for us. And this is essentially just a key value pair of the different services that we've created. And what I'm kind of interested in is the client ID, because I'm going to need to basically sign in to the GraphQL API simulating this client that we created. So I'm going to go ahead and copy this, and then I'm going to go back to the terminal, and I want to go next and create a new user in our Cognito service. And the way that we can do that is we can run amplify console auth, and this will go ahead and open up the Cognito service that we just created and allow us to go ahead and create a couple of users. I'm going to go ahead and choose just a user pool. And this should go ahead and open the user pool for you to go ahead and interact with. So I'm going to go to users and groups. I'm going to go ahead and create 2 new users. So the first one is going to be a Dabbit3. The next user I'll go ahead and create is So we've created 2 new users. Now we can interact with our GraphQL API by signing in as one of these 2 users. And the reason we created 2 users is we want to show how the authorization works, how if we create something and we try to access or update something and we're not that person, we should not be able to do that. So we're done here. Let's go back to the command line and now open up our GraphQL API, and we can run Amplify console again, but here we want to run Amplify console API. This should go ahead and open up the GraphQL API. Okay, great. So here we are. The first thing I'm going to do is notice that we're in the queries section of this API. I want to go ahead and log in with user pools. So I'm going to go ahead and paste in the client ID that we copied from our AWS exports file. And I'm going to go ahead and sign in as Dabbit3. And this should set us up and let us reset our password because we set that manually. We're going to go ahead and reset it. And now we should be good to go. So the first thing we're going to do is we're going to go ahead and create a new mutation of create post. And here we just want to go ahead and create our first post. And if we're not sure, we can go ahead and look at the documentation for what the post input entails. So we just need to pass in a title. I'll call this post 1. And I'll just return the ID and the post and the title actually. So post 1, let's go ahead and create post 2, post 3. Okay, so now that we've created a couple of posts, let's go ahead and list our posts. So let's go ahead and create a query called list posts. And this will be returning an items array with an ID and a title for every item in the posts array. Okay, great. So everything seems to be working properly. Now let's go ahead and sign out. And what we want to do is sign in as another user. So I'm going to go ahead and sign in as Lily. And now I'm signed in as a new user. You should notice that we should be able to go ahead and list all the posts still, because we set queries to null, so there's no different authorization rules on the query. But let's go ahead and try to update a post that was created by someone else. So I'm going to go ahead and create a new mutation called update. And this is going to take in an input that takes the ID of the post. And I'm just going to paste in the ID of a post that was created by someone else. And I'll return the ID in the title. And then I want to change the title of this post to Post from Lily. You should notice that we get some type of error, and we're getting the conditional check exception. And this is essentially saying that we cannot make this update because we are not the person that created this. So let's go ahead and create another post from me as the current logged in user. And now let's go ahead and try to update this post. We're going to change the title to New Updated Post. And now when we query for our list, we see that we were able to successfully modify that post, but we weren't able to do that using someone else's post. So we've looked at the authorization, how that's kind of working so far. Let's go ahead and take a look at our base schema though for the entire app. You notice that we only created 3 base types. We created a comment type, we created a event type, and we created a post type. But you'll notice that we have all of this additional schema. This is what the @model directive did. It created all of this additional schema based on the @model type, giving us the mutation definitions here and the resolvers, also giving us the queries for all of the CRUD operations, as well as all of the subscriptions. So all of this stuff is kind of already wired up for us. The next thing we might want to do is create a comment so we can test out the relationships even further. So let's go ahead and list for posts, and let's go ahead and create a comment. And we're going to take the input, and we're going to go ahead and see what we need to do to create a comment. So what we need to do is have an ID, some content created at and comment posts, but we don't need to pass in the ID. We only need to pass in the content. We can say something like great post. We then want to go ahead and comment post ID, and this is going to be the ID of the post that we're commenting on. So we're going to comment, let's comment on post number 3. Let's go ahead and try to list this again. So I'll go ahead and copy the ID from here. Try this again. Looks like I'm having trouble copying this ID. So I'll go ahead and just copy this here for now. Well, let me go ahead and just let me try listing this one more time. And there we go. Okay, so let's go ahead and create the comment. And now let's go ahead and list the post along with the comments. So we also have a field that we can now get here. and we want to return the items array from the comments, and we just want to return the content on any comments. So let's go ahead and list posts again. You'll notice that most of the items come back with an empty items array, except for post 3 where we did create one comment. So you see that the relationships are indeed working. And what we can now do is create comments on a post, and that relationship is all already handled for us. So the last thing we want to do is demonstrate how we can return a sorted list. So what we're going to do is create a mutation for a new event, because that's the one thing that we haven't kind of looked at, is how to create an event. So what we want to do is create a list of events and then query for those events based on the time that they were created. So we're going to be working with this create event mutation. And the one thing that we might want to do though is right now in our query, in our type definition actually, in the event type, we have a hard-coded created at and a hard-coded query name that is a required property of this. And what we might want to do is, if this created at property can be auto-generated for us on the server in some fashion, or maybe we can just generate this value in the resolver, that would be great. That way we don't have to pass in the created at, because really as soon as this item is created, it's just going to be doing a calculation. And if we can do that on the server, that would be great. The other value that we might be able to handle in the resolver is the query name, because the query name is going to be the same, because we're just using this query name as a way to perform queries on the global secondary index. So let's go ahead and change the resolver by going into schema, looking for the mutation for creating an event. And what we want to do is we want to make sure that the created at value is auto-generated for us, and also we want to make sure that the query name value is auto-generated for us. Now, if you look at the request mapping template, this is what goes and interacts with our database. This is the operation that's going to be setting a put item essentially in our database. You'll notice that the created at value is already being generated for us. The only thing we really need to do is generate the query name. And you'll notice that we have an operation that adds a new value to our input object called type name. Let's go ahead and add another value called query name. And this is going to go ahead and set all of the operations that this operation creates to add a new query name property called event. And we already have the created at value being saved there, so we should be good to go. Let's go ahead and save that resolver, go back to our schema. And now we want to look at the create event input, because this is the actual input that we're passing in. We want to make sure that we're not having any required values that we don't actually have to pass in. So instead of requiring the query name, instead of requiring created at, let's go ahead and make those optional. In fact, we might be able even to delete the query name property since we're not using it at all. We'll go ahead and save that. Now that our schema has been updated, we'll go back to our queries, and we'll now create a mutation for creating an event. So for an event, let's go ahead and take a look at what we now need. The only thing that's required is a name. So I'll just call this event 1, because we want to create a bunch of events and show how we can query for these based on the time that they were created. And for the return value, I'll return the ID, the name, and the created at values, because we'll now see that this created at was generated for us on the server. So there's event 1. Let's go ahead and create event 2, event 3, 4, 5, and 6. Okay, so we have 6 events created. Let's go ahead and do a basic query to kind of see how these events are going to come back in a random order. And then we're going to look at how to bring these back in an ordered fashion. So we want to go ahead and do a query for list events. And list events is going to go ahead and return an items array. And we'll go ahead and return the name, ID, and created at for every one of these events. And here we see that we have event 6, event 2, event 3. So this isn't the right order. We'd like to have these events come back in order. So what we can do is now, instead of using this list events query, we can instead use the items by date query. And what we want to pass in is the argument for the query name. And the item query name is event. And now let's run this query again. And now you'll see that we have the events coming back in an ordered list. So we have event 1, event 2, event 3. They're coming back sorted using that sort key that we passed in of created at. So now you can basically model any of these different types that you are creating in your GraphQL schema and have whatever sort key that you like. So when you start performing queries against your database, you can have the queries come back in a ordered list on the server as opposed to having to deal with that stuff on the client. Well, that wraps up this webinar. Thank you for attending. If you have any questions, you can reach me on Twitter. I am Dabbit3, D-A-B-I-T, number 3 on Twitter, and thank you for watching.